Hello. So, in this video we are going to be talking about how the degree of a polynomial sort of interacts or dictates whether or not that polynomial has an absolute extrema. Okay? So, degree and absolute extrema. So, one of the things that we sort of want to think about or want to sort of consider with functions in general is what we often call n-term behavior. And what we mean by this is how does the function work, or what's the function do as x gets sort of very large? And what we mean by that is sort of really far away from zero, either positive or negative. Now, with polynomials in particular, we sort of discussed about how it behaves like a leading term. And one of the reasons for this is that the leading term sort of magnifies the event the most, and we're going to see an example of this. But most of the time, when we're talking about how a degree interacts with something, it breaks down into even and odd degree, and that's pretty much what's going to happen here. So, even versus odd degree. Now, if we take some number, specifically a negative number in our case, and we raise it to a power, the reason why the even and odd degree thing is going to make a big difference is that how even powers sort of react to negatives and how odd ones do, that comes out to be very different in an important way. So if we take something like 4, right, some even power, we take the negative to that power, we get some very large but positive value, right? So if we compute that out, we get whatever that is, million, billion, trillion, I guess. Whereas if we took that same negative number but we raised it to an odd degree, like 3, we get a very large but negative value, right? So here we get a negative a billion, right? Importantly though, the fact that it's positive or negative, that's a byproduct of the even-odd part, right? So if we just took a positive number, no matter what we sort of raised it to for even or odd power, we get large positive numbers, but the negatives have different behavior. That's why we end up with something like a quadratic. An even power ends up having this sort of nice parabola shape where the ends are sort of going in the same direction, because if we go very large and positive, it's positive, but if we go large and negative, that even power makes it a positive value, so it also goes up. In contrast, if we take something with an odd power, like x cubed, going to the right, getting large and positive, that's going to go up and positive. But going left, getting large and negative, that gets large and negative, so it goes down a whole bunch. Okay, so this is the idea. We split it into even and odd power parts because of how that sort of makes the left side of the graph work with the large negative values. All right, so if the leading term is an even degree, meaning the polynomial is then an even degree, the ends are going to go in the same direction, right? They both get large and positive. So for example, if we have some function here, and we sort of don't know anything about this function, except for the fact that it's a degree 4, because the leading term here, 3x to the 4th, is an even thing, right? That's the only thing that we know about this. Well, we want to graph it, we put up a graph, and we know that both of these things are going in the same direction, right? If I get sort of large and negative x value, right, if I go to the left, I'm going to put it to an even power, and it gets large and positive. Over here to the right, if I get large and positive to an even power, also still positive. Even if I know nothing about what's in the middle, right? I'm just like wild scribble because I don't know anything about how this thing actually looks. I do know that the n-term behavior, if I go sort of out far enough, that's going to be large and positive in both cases. But what that tells me is that there's sort of a bounded area, like from somewhere to somewhere, which in my scribble is sort of over at this part here before it goes up, and over here before that part goes up. Between those two parts, it sort of can only get so big in either direction. It may never go up. I don't know if there's sort of like a peak part, but I do know that it can only go down so far. And what that tells me is that there's an absolute minimum somewhere, right? Because it can't go down forever, because if it tried to go down forever, it wouldn't work. I wouldn't be able to come back up again, right, as I'm going to one of the sides. So there's got to be some lowest point in here somewhere. So that tells me an absolute minimum definitely exists with this function. Now, to be very clear, you could graph that function. that is not this graph, right? But that's sort of the point, is without actually graphing the function, without knowing anything about this function, I know because it is an even power, right, it has an even degree polynomial, that this thing, it definitely has an absolute extrema, in this case an absolute minimum, because I know they're both going up in this case, okay? All right. So even degree polynomials, they always have an absolute extrema. But that one, I was talking about an absolute minimum, but it's totally possible that I would multiply with a leading coefficient that is negative, right? And remember from when we talked about sort of translations, transformations, stuff like that, if you're multiplying by a negative, it's going to flip the y values. So what used to go sort of up in both directions, now they're going to go down in both directions instead, because the leading coefficient is a negative number, right? So it flips everything. But then the same sort of argument applies, right? I could sort of, whatever's in the middle there, I don't know what it is, but whatever's in there, it can only sort of now go up so far because it has to come back down eventually, right? And so because the leading coefficient is negative, that tells me that this thing has an absolute maximum somewhere, okay? Again, to be very clear, this is not the right graph, and that's sort of the point, right? I don't need to know the graph in order to know this fact, okay? All right. What if we have an odd degree? Well, as we sort of saw before, right, the whole thing with an odd degree is that if I go sort of in the negative direction, it's still negative. If I go positive, it's still positive, meaning that the ends go in different directions, right? So again, whatever sort of happens in the middle, I don't know what that is, but eventually it goes infinitely far up and eventually it goes infinitely far down, which means it can't have any absolute extrema. It can't have an absolute max, can't have an absolute min, right? So again, because they go in different directions, you don't have any absolute extrema. And to be clear, again, still not the real graph, still kind of the point, okay? So takeaway here, even degree polynomials always have an absolute extrema. Might be a maximum, might be a minimum. That depends on the leading coefficient. Odd polynomials, meaning odd degree polynomials, never have an absolute extrema. No matter what the leading coefficient is, as long as it's, an actual odd polynomial, it won't have one, okay? So what do we do? Well, we talked about how the degree and the absolute sort of extrema, how they're interrelated, and the fact that even degree polynomials, those always have some sort of extrema. You have to do a little bit of work with the coefficient to tell whether it's a max or min, but they will always have an absolute extrema, whereas odd degree polynomials never have an extrema, okay? So that is that.